Hello everyone, and welcome to our first day of a new unit. In this unit, we are going to be learning about a new type of function that is going to be called an exponential function. So, exponentials and this equation is going to be in our form y equals a times b to the x. Okay, so just looking at our equation, what might your definition of an exponential function be? What's different about it? So you might have said that the variable is in the exponent. Right? Our x now is in the exponent. Isn't that cool? Alrighty. So this time, the function has an exponent of x. Okay, and that's a great way to start with exponentials. The exponent is an x, or our x is in the exponent, okay? Because so far we have talked about linear and quadratic and cubic, and those were exponents of actual numbers. Now we have an x, and so that's going to be the main feature of our exponential functions, okay? So let's talk about an example. If we look at examples of exponential functions, let's just do an easy one. An example might be y equals 3 to the x. And so because we have an x in our exponent, it is going to be an exponential function. All right, let's do another one. We could have y equals 1/2 to the x. Just because there's a fraction in our parentheses does not mean that it's not an exponential, because we have an x in our exponent. All right, we could have y equals 4 times 8 to the x. Now, why isn't this just 32 to the x? Hopefully because you said that our exponent only distributes to what is inside of our parentheses. So if this was a 2, if our x equaled 2, we would do 8 squared, and then we'd multiply by 4. Always remember your order of operations. Let's see, another example could be y equals 6 times 1/3 x plus 2. That's entirely possible, and we're going to see one of those. And we can also see y equals 7 to the x minus 1, and then plus 5. We could see one of those. So all of these are all exponential functions. Okay? All right, so then what's a non-example of an exponential function? What is not an exponential function? Well, any number, a constant, is not an exponential function, like 5. That's not an exponential. Or 2x, because we have to have an x in our exponent. Well, this has an exponent of 1. Okay, what about, let's see, 3x squared? Well, this time we have a 2 in our exponent. That's not an x, we need an x. Okay, so then what about, is that one? No, because we do not have an exponent. Or, sorry, we don't have an x in our exponent. Okay? Alrighty, so we are going to skip characteristics for now. That is something that we are going to be learning about a little bit later. Okay, so today is just kind of our introductory, getting to know you type of deal. Alrighty, so now we're going to flip to the back. And these are actually going to be our characteristics. I'm just kidding. So, sorry guys. It's skip for now, is actually on the back. All right, so on the back. Okay, you guys ready for characteristics? Okie dokie. So we have key features of exponential functions, and a great way to start out exponential functions is to, let's just have an example. Okay, so let's see, if I do, let me think of a good one. Let's see, I'm thinking about, do here, and then here. Okay, so I have listed out the points 0, 1, 1, 3, and 2, 9. Okay, and so this is what an exponential function looks like. And for this equation, it's going to be y equals 3 to the x. So I came up with these points by making a table of values for my x and my y. So when x was 0, if you do 3 to the 0 power, you get 1. If you do 3 to the first power, you get 3, and then 3 squared will give you 9. So that's how I came up with that, okay? So all of our graphs are going to look something like this. They could also look like this, okay? They could also look like that. And finally, they could look like that, okay? So we have 4 different ways that our graphs could look. Alrighty? So we are not going to talk about intervals of increase or decrease, but we are going to talk about an asymptote. Does anybody know what an asymptote is? Alrighty, so an asymptote is an imaginary line that our graph never touches or crosses. Okay? So never ever touches or crosses. And it will always, for exponentials, be in the form y equals. Okay? So it's going to be a horizontal line. And as we know, horizontal lines are y equals. Okay? So we denote our asymptotes on our graph by a dashed line wherever our asymptote is. And our asymptote for this equation happens to be 0. So for this equation, for this example, our asymptote is y equals 0. Okay? Alrighty. So we do have positive and negative intervals. Positive and negative intervals are where, or is where, the function is above, which you guessed it, that's going to be our positive interval, or below, which is our negative intervals. And that's all in relation to our x-axis. Okay? Alright, so then, if we look at, whoops, making sure that you guys can actually see that, sorry guys. If we look at our example, is there a single spot where my red graph is below my x-axis? No. So this entire graph is going to be a positive interval. Good. Okay? Alrighty. So we're not going to talk about end behavior today. We'll talk about that a little bit later. We are, however, going to talk about our x and our y-intercept. So if you remember, our x-intercept is where it crosses our x-axis. But if we have an asymptote at x equals 0, are we ever going to get an x-intercept? I'm hoping you said no. And the reason why is because our graph is above our x-axis. And it will get closer and closer and closer to the x-axis, but because we have an asymptote at our x-axis, it will never touch or cross it. So for our x-intercept, we have none. What about our y-intercept? Do we have one? Yes, we do. So what is it? There are two ways you can determine this. We can either look at the graph or look at our table. So if we look at our graph, it's where our graph, our function, crosses the y-axis, which is right at here at 1. If we look at our table, it's where our x equals 0. And then we go over and y equals 1. So we would have our x-intercept as y equals 1. We could also write it in the coordinate point 0, 1. Okay? Alrighty, now domain and range. This is something that we have talked about before, whether you remember it or not. So if we talk about our domain, we are going from left to right. So if we start at our leftmost point, what's there? It's an arrow. Good. So what happens when there's an arrow at our leftmost point? Right. That's going to be negative infinity. And then we go to our rightmost point, and that's going to be positive infinity. Good. So another way to say negative infinity to positive infinity, wow, is this thing called all real numbers, which is denoted by a line and an R. Okay? And so from now on, our domain is always going to be all real numbers. So anytime you ever get a graph in algebra, in my class, the domain is always going to be all real numbers. Always. So if I ask you for the domain, what are you going to say? All real numbers. Okay? That is what I want you to say from now on if I ever ask for a domain. All real numbers. Okie dokie. So now we're going to talk about our range. So if we go from bottom to top, and range is going to be a little bit different this time. We still go from bottom to top. Okay? And we start to hit our range at our asymptote. And then we continue to go up, 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 up. Okay. So for our range, I want you to state what your asymptote is. So for our range, we are always going to put y, and then we're going to put our asymptote. Our asymptote is 0. So all you have to do is figure out if your graph is above your asymptote or below your asymptote. Since our graph is above our asymptote, y is going to be greater than 0. And that's it. That's our range. Okay? Alrighty. So we have done a lot today already, and we have more to do. We have talked about our definition of an exponent. It has an x in the exponent. Okay? We've given some examples of exponentials, which, if you notice, all have x's in our exponents. We've talked about non-examples, which do not have x's in our exponents. Then we talked about some key features or characteristics of our exponential functions. The main ones that we are focusing on right now is our asymptote. This is the biggest one we need to focus on. We also, as always, talk about our x and our y-intercept and our domain and range. What's our domain of any and all graphs? All real numbers. Good. Our range for exponentials will always include our asymptote number, which was 0. Okay? Alrighty, this was a lot of information, but we are going to carry on with our next page. I will see you in a minute.